Alright, so here we are. We got another homework solution. This is for homework 17. And problem 1, we have a mechanism that has it's made up of a disc with a pin in it. That's disc AB. And the pin is at B. And that disc is rotating at a constant counterclockwise angular velocity of 4 radians per second. The disc has this radius of 6 inches. That's the distance from A to B. And at the instance shown, that angle that's made with vertical is theta A of 30 degrees. And we notice that this bar with a slot in it, call it CD, it has B sliding through it, and at the instant shown, it has an angle of 60 degrees. And the length between C and B at this instant is 18 inches, and the length between B and D is 6 inches. So we want to determine the angular velocity, angular acceleration of bar CD. Now, what makes this a little different from some of the other problems that we've dealt with so far in rigid body kinematics is this length right here changes, this length BC. And so but it's also rotating, and the combination of having a length change and having a rotation will bring up Coriolis acceleration. So if I were to bring in our equation sheet, it would show up, this trait would show up down here with rigid body relative motion on a rigid body. Okay, so for velocity, that's going to represent something we call VREL, which is going to the relative velocity, and which is going to actually be closer than anything else that we've had so far to being R dot. You can think of R dot and VREL as being very, very similar. So you could also see that what we have is this R theta dot in the polar motion right here is really represented by this omega RB with respect to A, right? So that's being like, the omega is like R dot, and then the R is just like the RB with respect to A. And then in a similar way, what we'll find in acceleration is we have this AREL, this relative acceleration. And that's going to be very, very similar to R double dot right here. Okay, that's the length of the thing increasing or decreasing, at the rate at which it's moving, the rate at which is increasing or decreasing, right? So as R dot was the VREL, R double dot is the AREL. We also have another term here. We have 2 times omega crossed VREL, right? That relative velocity. Well, that's the same thing as we would have up here with 2 times R dot theta dot in polar coordinates, right? So it's these are rigid bodies, but they're having some of the same traits that we saw in particles. Right, so let's get to this. I think I have to turn the camera on, and let's see if it works correctly. I might have to monkey with some things. It's gonna go correctly for me. Oh, it's getting angry. It's not showing up. It's showing this view, which is the back side camera. There's some glue and a soldering iron over on behind the laptop. All right, here we go. So here is the problem written out, and what we're going to use in this case, we're going to, I've decided maybe I should write this in the problem. You can see I used the Word document for the problem. I might write out and say, use vector stuff instead of using the 3 diagrams for this. I think it's just good practice, right? So one of the first things that we can do is, I think they've cheated a little bit in this. Is that true? 1 second. Okay. Anyway, so let me write out. I'm going to use the this guy right here. All right. So first off, we have to do a velocity analysis, and the big idea, or the thing that we'll find repeatedly when we do, is we can figure out the velocity of, or the acceleration of B in two different ways, because we have two different rigid bodies, if you can think of them in that respect, right? So we could write out the velocity of B because we know the velocity this way, the velocity of the disk, but we can also write the velocity of B because we have maybe the setup to what's happening with this bar. And we equate those two things, and that allows us to find the things that we don't know. This problem is probably a little more straightforward than the second problem, but that's one of the reasons why I bring it up. So when it comes to the disk, we are using this basic equation right here, right? This velocity equation right here. And then when we're talking about the bar, we can use this equation right there. All right. So like I said I was going to do, I'm going to bring this over to the other screen so I can see it and write it down at the same time. Let's see if it will get up there for me. There you go. Come on. All right. So the velocity of B with respect to the disk is going to be, I should probably have done this problem out, but ahead of time, right? No. With respect to the disk, it'll be the velocity of A, which is fixed, of course, plus omega k crossed with r b with respect to A. All right, so this is omega AB. And omega AB is going to be 4, but it's a positive 4 because it's counterclockwise, k radians per second. RB with respect to A, maybe I should give myself some more room to do that. RB with respect to A is going to be negative, right? Because it's 2, we're going to B with respect to A, so we're traveling in the negative direction here, and this is 6. But we're going to take the sine of our, did we say what theta A was? I think in the problem statement, did I say that? I hope I did. That's something I would want to say. Oh, it's 30 degrees and theta C is 60 degrees. So I didn't write that down in my givens. Darn. Theta A is 30 degrees. And theta C is 60 degrees. I should have written that down. Okay, so this is 30 degrees, I, plus, and we're going upwards, so that's going to be 6 cosine of 30 degrees, J. And these are inches. So I will say that RB with respect to A is going to be 6 times the sine of 30, or 3. So it's a negative 3i plus 30 cosine, and that becomes a 5.196 J inches. All right. So we could find the velocity of B is going to be our 4, and we could do the distribution of this as one step, maybe negative 6 omega AB crossed with I. Nope. K crossed with I. I'm sorry. K crossed with I, plus my, why did I just do that with the 4? Why did I do that with the 6? Maybe I should start the video over. Nah, we're going to keep going. Keep on going. 4 times negative 3. There you go. Get your head in the game, boy. Right there. Then we go 4 times 5.196, and this is K crossed with J. Did I do that right? I think so. So we get the velocity of B is going to be equal to, well, this is easy, right? Negative 12 Oh, well, maybe I should just, I'll do it the other order. So I'll make it I and then J, because it looks better that way, right? So this becomes J, and this becomes negative I. And I'm going to write this one down to the next line below. So for the I, we're going to get 4 times that 5.196, and it's going to be negative. So it goes 20.79 I, and then we're going to have a negative 12. Maybe I'll give it 2 more sig figs. J, and these are inches per second, right? Easy enough. Although this video has gone really long already, isn't it? Wow, I'm already 10 minutes into it, and that's as far as I've gotten. I need to go a little faster. Okay, so for the velocity analysis, we need the relative velocity first. So we're going to use the other equation for the velocity of B. Velocity B can also be found out, whatever the angular velocity of this thing is going to be. So we're going to write down the, we'll write down right here, the main equation that we're going to have is the velocity of C, right, plus omega, we'll call it CD, let's see, we'll write it out. Yeah, it's written down in 2 dimensions, so we'll keep it in 2 dimensions. CD K crossed with R, B with respect to C. All right, and we're doing that correctly, yes. And then plus the relative velocity here, which, okay, so is a symbol. We say that it's the relative velocity. Trying to think how I have written this before. I think it's going to be the relative velocity. I don't know. I don't write these problems very often, so I want to be consistent with how it's written in the book. So let me take a peek in the book. Okay, so I'm going to use I'm going to use my own personal preferred convention for writing this right here. So now I'm going to say that it's going to be B with respect to C rel. Okay, so that's how I decided to solve this naming type of thing. To make that relative velocity exactly what we're saying, right? So B is moving with respect to C in a relative manner, because B is not attached to CD. So we can't treat it like as such. So this is usually going to be B with respect to C in terms of that regular B with respect to C. But here's a B with respect to C that's a relative velocity. And it really is like the essence of why this is sort of a different scenario, this rotating reference concept. So I'm going to need to have, so first off, this is going to be along a line of action. So it's going to be a magnitude VB with respect to C. It's the thing that we're really kind of going to be looking for, or it's an additional term right here. But we do know the direction that it has to be. It has to be along this line of action. So I'm going to treat it like it's going to be positive. So I'm going to say that it is a V rel with respect to this, and it's going to have a magnitude that follows along this line of action. I think I can say that. Shoot. 1 second. Dang. I think I have a problem. No, I'm good. I'm good. Okay. So let me write these down separately. I'll go, let me write this guy down first, because it's just, I guess maybe I'll write, no, this is fine. This is just a value. We don't know what direction, which means we're going to assume that it's counterclockwise, essentially. We can find RB with respect to C. Both of these are going to be positive because we're going to B with respect to C. So it's just LBC times, oh, and I didn't put this angle in here. Let me see. That's a theta C that needed to be written in there, right there. All right, so that's the 60 degrees we have right there. All right, so we're just going to take that LBC, which is 18, and that's positive, and we're going to take a cosine of 60 I plus our 18 sine of 60 J. And 1860, it should be half, right? Yeah. So that's going to be 9 I plus 18, and then 60 sine times, so we get 15.59 J inches. Okay, great. So this relative velocity thing, we need to write it out as V, B, C, comma, rel is going to be V. I'm just going to call it BC. I'm going to leave off the L. Maybe I should keep the L in there. I guess so. I'll keep the L in there. Why be lazy? Okay. And that's going to be, let's see, I'm going to choose it positive. So it's really going to be the same as this down below right here, right? It's going to be the cosine of 60 I plus VB with respect to C rel sine of 60 J. So we'll write it down below. So I know that's going to be 0.5 VB with respect to C rel, and then I plus 60 sine is going to be 0.8660 VB with respect to C rel. All right, my office hours are starting soon. And if we cared, this is going to be inches with respect inches per second, right there. All right, so what we do now is we want to write out this whole thing. I'll write it out in 2 steps, or maybe a couple steps, but here. C doesn't move, so that's nice. That's a good thing, right? So we would have a problem, but not necessarily a problem, but it would be something if this thing was floating in space and moving that we would need to address. Even more confusing was about rotating in space, but I think we're fine with respect to that. Okay. Yeah, Lucy, excuse me. Omega, this is something we don't know. So we go omega CD, and that's going to be times R right here. That R, we just found 9. K crossed with I, right? And then plus omega CD times 15.59, and that's going to be K crossed with J right here. And then it's going to be plus this guy. Plus VB with respect to C rel, and damn, I'm not gonna have enough room. At 0.5 VB with respect to C rel I plus, carry it down here, 0.8660 VB with respect to C rel J. And this is J, and this is negative I. So we want to equate this with this up here. So we'll write them out. Negative 20.79 I plus negative 12 J is going to be equal to, and I'll put them in this order right here, negative 15.59 omega CD I plus 9 omega CD J, and then plus our, I guess I've decided to put these things in front. No, I'm okay right there. No, it's up here. It's 0.5 VB with respect to C rel I plus 0.8660 VB with respect to C rel J. Now collect the I's and the J's. I know. This is an extra difficult setup here simply because of it being relative motion. So 1 continued, ... And I will say, okay, so the I's. And we're going to end up with 2 equations and 2 unknowns, so we're going to have to solve them. It's not as easy as some certain problems where, you know, we could just go to one and come up with it and solve the thing we want to know and plug it back into the other. This is, we'll have to do a simultaneous solution of some sort. So for the I's, we got negative 20.79 is going to be equal to negative 15.59 omega CD, and then plus 0.5 VB with respect to C rel. Right, there's one equation. And then J, we will have as negative 12 equals, and then 9 omega CD, and then plus 0.8660 VB with respect to C rel. So 2 equations, 2 unknowns, and we can solve them. I think the strategy I want to go to is to divide all of this by There's a couple different ways to do it. I think I'm going to solve for this and then plug it back into here. All right. So VB with respect to C rel is going to be equal to, right? So I'm pulling all this over to the left-hand side, and I will say it's negative 20.79 divided by 0.5, and then I'm going to have, this is going to turn into a plus, right? So maybe I'll do it in 2 steps. Negative 50 minus, yeah, I get it. Omega CD, but we're dividing by 0.5. So I'm going to end up with 20.79 really times 2, right? So a negative, didn't do that right. 20.79, there you go. Negative 41.58, and then we're going to have a plus, that's divided by 0.5 as well, so that's a plus 31.18 omega CD. Now I'll put him back into J, so I get a negative 12 equals 9 omega CD plus 0.8660 times my negative 41.58 plus 0.8660 31.18 omega CD. Now I can find omega CD. Got to be careful here. Okay, so this is negative right here, but it's going to come over there and become positive. So first I'm going to multiply 41.58 by 0.866. Boom. I get 36.008. He's going to come over there. He was negative here, so I'm going to subtract 12 from that. Gotcha. So now I'm at positive 24.008 right here. Now I'm going to add 9 plus my 0.8 times that. So 31.18 times 0.866. Boom. And that should be positive. Double checking that. I think it should be positive because that negative. All right, so positive. I'm going to add 9 to that. Now I'm going to divide through, and I get an omega of 0.6669 radians per second, and I get it positive. So this too is moving in counterclockwise, right? And then I'm going to and now I'm going to put that back into this guy right up here. So I'll go VB with respect to C rel is going to equal, well, we said negative 41.58 plus my 31.18, and now times 0.6669 and 31.18. Double check in there. Yeah, times. Okay. And now I'm going to, okay, so that, I still have that in there. Yeah, so subtract that out. Oops. Interesting. Yeah, that it just comes out to being 20.79. Huh, it comes out half of it, 20.79 inches per second. Interesting. Okay, so let me see here. Let me double check that I got that one. 41.58 and 31.18 and 0.866. Nope. 0.6669. Yeah, and then subtract. Yeah. So that's okay. So I might change what we're trying to find here because this is going to be a really long problem. I don't know. Let's see. I'm already up to 27 minutes, and I got to get onto my office hours. I better pause. Okay, so, well, we might as well soldier on through. I think the learning will be worth it, and get the acceleration right here. So here's the velocity analysis. Here was the acceleration. We needed this velocity analysis to do the acceleration analysis. So the big equation that we want to write, well, first we have two equations. Okay, so first we have to do an acceleration analysis of, and this seems to have jumped over to the wrong side. Let me move this over here. Oh, come on. I'm moving it over to the other screen. It takes time. Maybe I could edit this video. No, it takes too much. That takes too much time too. All right, so anyway, we want to write out the acceleration analysis of really just a fixed axis right here. So we could just write this guy right here, this equation for my acceleration of b. So the acceleration of b is going to be equal to the angular velocity of k, let's say of AB, k crossed with r, b with respect to a. Well, I'm going to write it out to be consistent with the other thing. So I'm going to write down this one down here, right there. All right, so we want the acceleration is acceleration of a plus the angular velocity of AB, k, crossed with RB with respect to a, minus omega AB squared times RB B with respect to A, right? So we have a little bit of a simplifying thing taking place here because, first off, that's 0. That's good because, right, this thing is fixed right here. So we don't have to add. We were told this was 0, that this was a constant. Right underneath there, constant. It's a good idea, right? A constant. So this is 0 as well. So all we're left with is this, and we already know this RB with respect to A because we got it over here before. So the acceleration of B is simply going to be negative 4 squared, right? Because this is 4 squared, because that's what that is, times RB with respect to A and the X, so that's a negative 3 and I. And then I'm going to say minus, because that thing's still a minus right there, 4 squared, and then that's 5.196. 5.196, and that's going to be J. So we see that's a minus minus, that's going to be nice, and that's going to be 16 times 3. And so you get 48, so that's going to be 48.00 I. And then so that's going to be, I like to stick the minus signs inside the values there. So I'm going to have 16 times 5.196, boom. So you get negative 83.14 J, and these are inches per second squared. All right, so there's the acceleration of B. Now we're going to write the acceleration of B, and this is going to be a long one. We will write it out this way right here. All right, so we're going to write it out with all of these things inside them. So there's the acceleration of B is going to be equal to the acceleration of now C, because that's the one we're talking about. We're rewriting this out for this other part right here, right? We wrote out just now what the acceleration of B is because of the disk. Now write out what the B is if it was because of this rotating reference frame type of thing. So that's why we're doing it twice, just to be clear. So we're writing out this equation right here, and maybe I should maybe show these at the same time somehow. I don't know how. This thing is not wanting to get smaller on me. Yeah. All right, so let's see. Okay. Writing out that equation right there. So we go plus alpha, and this is going to be CD K crossed with R. Now we're going to go C with respect to B. No, B with respect to C. Sorry, B with respect to C. And then a minus omega CD squared R B with respect to C, and then plus the acceleration, and that's going to be the relative acceleration, and that's going to be B with respect to C rel, and then one last one, plus 2 times. And we're being a little bit of a jerk here. Yeah, we should actually probably wrote it out this way. Omega CD K crossed with V C with respect to D, B with respect to C. B with respect to C. Rel. Okay, good. So let's so that is this equation right here, except that I didn't make this into 2 dimensions. That should really look similar to like what's up here, right? Except that this B with respect to this R right here should be this VREL right there, right? So that's the same thing that we're doing. All right, so hopefully that wasn't too devastatingly confusing. So we should write out some of the things maybe separately. Okay, so first off, nice, glad to hear it. That is not 0. Something we want to find. We know this. We know this. We know this. This is something we need to find. We know this and we know that. All right, so we have all these different elements. We have to do them. I think it's going to be, this is tedious, but we have to go through it. All right, so let me write out what this one is. No, I could do that later. I could do that later, just as long as I've already recorded what our B with respect to C is going to be. I have it right down here, right? That's this guy right in there. This one, yeah, no, I guess I can write him later. Here I do need to write this out right here. So I'll say that the A, B with respect to C, I'm going to do the same thing I did when I had this guy right here, right? I don't know the magnitudes of him, but I know the directions. So I'm going to stick him in with an A, B with respect to C rel times my cosine of 60 I plus my A, B with respect to C rel sine of 60 J right here. And I guess I will come down to the next line because I need to leave myself enough room. But the cosine of 60 should be 0.5, yes. So 0.5 times my A, B with respect to C rel I plus, and this should be, I guess I could remember, 0.8660. There you go. A, B with respect to C rel J. Now I'm going to do this guy right in here, and I guess I'll write him out. Maybe I'll only write him out once. C with respect to D. Nah, I guess I'm going to, yeah, I could do it as I go along. All right, so acceleration of B. All right, we already know the acceleration of B is this value here, but I'm just going to rewrite all of these things out and then collect them all together and then do the I's and the J's, and we'll have 2 equations and 2 unknowns. Those unknowns are going to be this guy and the magnitude of that. So we have omega CD times RB with respect to C, which is 9. And we know that that's going to be K crossed I, which we know is J. And that's going to be then plus omega CD times our 15.59. And that's going to be K cross J, which we know is a negative I. Right, and this thing's going to go many different lines right here, unfortunately. Then we're going to have a minus, and that's going to be this omega squared, right? So 0.6669 squared times 9. All right, and now we're going to continue on. Make sure we remember that that's going to be negative, but we have to continue on to the second part of this, which is going to, now I'm going to come down to this way, 0.6669 squared times our 15.59 J, right there, right? That's this. Now I'm going to hit this guy right here, which is this term, plus my 0.5 AB with respect to C rel. Yes, and then I have to add this other one. Oh, I, dummy, I, plus 0.8660 AB with respect to C rel J. All right. And then we're going to do this guy right here, right? So then we're going to go plus to say that we're going to keep on going. And that could be a long thing because we're going to go 2 times omega CD, which is 0.6669, right? But we need its I component. So what we have right here is we need this value, which is this value right up here. So 20.79 K, and then we're gonna okay, so we've crossed K. Oop, I'm not done. Darn. All right, so that's this is the magnitude of the entirety of the VREL, but this is a vector, so we need to go back to where we initially got that, and so that's going to be that magnitude times 0.5 times I. Yeah, I should have done that, written that out again, probably. All right, and then that's K crossed I, right? Because remember that this was K crossed this, so it's K crossed I. Plus the same thing again, 2 times 0.6669, and now the magnitude 20.779, and then times 0.866 times J. Oh no, K cross J. Okay. So 0.8660, and then that's going to be K crossed J. We happen to know that this is negative. No, negative is positive. Positive J. And this is negative I. Whee! That's a lot. All right. So let's rewrite out acceleration of B. And let's go, I'm going to do this one first, is I, right? So it's just going to be, I'm going to put the number first, negative 15.59 alpha CD I plus 9 alpha CD J. Right there, right? This is next, so let me get this number, 0.6669, and that's squared times 9 comes out to, and that's negative, so, but I'll put them inside here, negative 4.003 I think I got that right. And then same thing here, right? So we're going to go that 0.666 squared and multiply him by 15.59. Boom. And I have irritating people texting me. Oh, it's not irritating. That's my wife. The pic didn't send. I'm having a good. Okay. So where were we? We were just going to write down an answer here. Yes, I think it's going to be plus a minus 6.934. 6.934, and that's a J right there. That was because of this term. Right, so now we're going to come down, we just write these out. So plus the acceleration of B with respect, I guess go 0.5. 0.5, the rel I plus 0.8660 AB with respect to C rel J. All right, and then these last guys right here. So we'll go first off this one over here plus and so we have 0.6669 times 2 times 20.79 times 0.866. Boom. And it's negative. So we get negative 24.01. And that's going to be I. And then last one we have is this plus, and that's going to be 0.6669 20.79 times 0.5 times, and I lost my train of thought. Poop. 0.669 times 2 times 20.79 times 0.5. And I get 13.87 J, and that would be inches per second squared. So I'm on page 3, and this problem is way too long. So I'm going to cut it off maybe at the earlier part right there, but we'll see. 1 continued. We're going to set the accelerations equal to each other. Maybe we'll just collect the i's, right? We know that that acceleration that we got way up here, this guy right here, the acceleration right here, that's going to be equal to this acceleration we just found. So let's just get the i's and collect them. So we have that equation. So we're left with that it's 48.00 is equal to negative 15.59 alpha CD plus negative 4.003 I plus 0.5 B with respect to C rel. I don't need to write that I. I'm being distracted by these texts that I'm getting. I'm about to tell the people who are texting me that they need to stop. I'm working. And then plus negative 24.01. Right? And I might call, I guess I have these as constants right here. You can see that I have the two unknowns. And maybe I'll leave some space. I guess I'll make this a little more succinct so I can get the algebra out of the way. Algebra, I guess it's just math, basic math. 48, and that's going to come over and I'm going to add to it. So 4.003 adds to it, and then this is also going to add to it. So 24.01 and add, and so I'm going to left with a 76.01. It's going to be equal to our negative 15.59 alpha CD, and then plus 0.5 acceleration of B with respect to C rel. And this one is going to be negative 83.14, if you'll recall. That's from back up here. And on the other side here, we have all of our J's. So we will have 9 alpha CD plus our negative 6.934 plus our 0.8660 a B with respect to C rel, and then one last one, plus our 13.87. And I'll rewrite this one out too. Since I have our 83.14 and it's negative, I'm going to add 6.934 to it. And then I'm going to subtract 13.87. So I get a negative 90.08. It's going to be equal to my 9.000 CD. And then plus my 0.8660 AB with respect to C rel. All right. And so now you could pick either one to try to do, but I'm going to take this one and the same way that I did before, just because it's a 0.5 makes it a little easier. I'll go A, B with respect to C rel. It's going to be equal to, well, first it's going to be that 76.01 divided by 0.5, right? And then now I'm going to bring this over to the other side, over to here, over to that side, and that's going to make that positive. So that becomes 15.59 and 0.5, and that's an alpha CD. Did I do that right? I think so. So 0.5 and divide, I get 152 plus my 15.59, and that's a 31.18 alpha CD. Plug him back into here. So I get a negative 90.08 is equal to 9 alpha CD, and then plus a 0.8660 times 152.0, that's 152.0, plus 0.8660 times 31.18 alpha CD. So that means I'll take that 0.866, multiply it by that, but that's going to become negative, and so it's going to combine with 90.08, and that's a negative 221.7 equals, and now we have 9 plus whatever that's going to be, so 0.866 times 31.18, and add it, and it becomes 24.87 alpha CD. And so we find that alpha CD is going to be, where'd you go? I made a mistake. Wait. Dang. 90.08. Gotcha. No, I'm cool. Okay with that. No, I just need to add 9 and 31.18, and we add them together. They do not equal this value right here. I must have hit the button wrong. That should be 40.18. Duh. And then I can take my 221.7, and what I find is I get a negative 5.518 radians per second squared. So that's actually the thing that we were trying to find, right? Yes, that's the thing we were trying to find as our main goal. And it took us a really long time. I mean, did it take us an hour? No, it's getting close to an hour. This is a really long video. In terms of an assignment, so we'll see. All right, Let me just think. Is there a way to make this a short question? I don't know. I'll explore this a little bit later. We should find the relative acceleration. So let's take the relative acceleration. This guy right here, b with respect to c, rel, is going to be equal to our 152.0 plus 31.18 times our negative 5.518. And so what does z turn out to be? 31.18 times him. That's a negative, and we have 152, right? So 152. So we end up with a negative 20.04. This should be inches per second squared. So the answers are going to be, let's see, we did all this as vectors, so let's answer it with as a vector. Omega CD is equal to, where'd we get? 0.6669, so 0.667 K. It's positive, therefore that's counterclockwise, radians per second. And then we could say that alpha CD is negative 20 point, nope, it's this thing up here, 5.52 K radians per second squared. That's a long enough problem. I think I might come up with a way to fix this thing by making it only a one problem homework because it's way too long. I don't think doing two of these problems would necessarily make it more learning. So I think that's what I'll do.